about in vivo research systems, there are multiple applications we cover. We cover blood pressure measurement, and when we talk about blood pressure, there are many like non-invasive blood pressure, invasive blood pressure, and then many variety in invasive blood pressure also, pulse oximetry, and those human systems I won't be talking much about that. Right. So if we talk about blood pressure measurement, we have a range of sensors and transducers which start from very lower to higher range. So if we talk about lower range, we have got transducer which is called physiological pressure transducer, and those are fluid filled transducers, right? So most of the places, especially in like education, where medical college and all, people use this because it's cheaper, it's price effective. And what they do, they fill saline in this, and they make a tubing cannula, and they open any artery, maybe femoral or carotid, they go inside, and that is connected to PowerLab, and then they record continuous blood pressure, systolic, diastolic, mean arterial pressure, mainly arterial pressure. Though they can record ventricular pressure also with that if they keep moving to ventricle. Now, if we move to the higher version of this, we have very fine gold standard Miller pressure transducer, Miller microtip pressure transducer. So those are from Miller. Miller is actually a US based company, and we are global partners, ADInstruments and Miller, from the very beginning. And these transducers are sold by ADInstruments, and they are very fine. They, again, I would say they are gold standard. So it's just a wire and the sensor on tip. So we have one with us if you just want to have a look. Jerry, can you just pass this? Okay. I mean, they are supposed to be used and throw, but I have seen many customers in medical colleges who are being using like for 6 months or 1 year to them also. So it works fine. So once we use this, we record invasive blood pressure, right? Which is beat by beat, systolic, diastolic, mean arterial, and all. Another system is non-invasive. So there's actually advantages and disadvantages for both the technology. Now, especially if I talk about academics and research where animal ethics is an issue, this system is quite popular. Because what you can do, you can keep using the same animal for a longer time. You don't need to kill. If you talk about invasive blood pressure, every time you do surgery, then you have to use another animal for next time, right? Disadvantage is like you only record systolic pressure. Or maybe diastolic you can calculate, but it's still under controversies. It's not like validity because this physiology principle is not allowed to that. And or heart rate maybe maximum. Systolic, though you have to kill animal every time, but you're getting multiple parameters and you're getting more accurate parameters like beat, mean arterial pressure, systolic, diastolic, and all. Right? So what happened in this system? This is a system which actually, this is a controller. It comes with tail cuff and a pulse sensor and a restrainer. So you train your animal to sit in the restrainer, attach this transducer, and this will give air, just like happening in human. Just like doctor measures blood pressure, same here. So first you connect so that pulse is coming. Then you give the air, it blocks the pulse. When it releases automatically the pressure, so you see the pulse is coming, the pressure is increased. It releases the pressure, and when it releases the pressure, pulse will start coming at some point. So the first pulse or first 2-3 average, if you take the first pulse is actually your systolic pressure. It's just like how doctor use it in humans, same.
The ML125 NIBP system performs non-invasive blood pressure measurements on mice and rats using specialized tail cuffs. The system provides a good estimate of actual systolic pressure, whereas diastolic pressure can be derived in LabChart, but is a less reliable measurement. The two main components of this system are the NIBP controller and a tail cuff for either mice or rats. This training video demonstrates the correct use of this equipment and includes a live demonstration of non-invasive blood pressure recording from a rat. Before Before performing blood pressure measurements, the subject animal must be introduced into an appropriately sized restrainer. In this instance, the rat weighs 210 grams, and we are using the rodent restrainer for rats weighing 180 to 320 grams. Once the rat has been introduced into the restrainer, the length of the restrainer can be adjusted to comfortably restrain the animal. A towel is placed over the restrainer to help calm the animal, and a lamp is placed close by to keep the animal warm. The tail cuff is slid over the subject's tail along the tail cuff holder until it rests closely to the tail end of the restrainer. The tail is also placed securely within the pulse transducer. Once secured, ensure that the pulse transducer is not in contact with the tail cuff, as vibrations from the cuff may affect the pulse signal. It is recommended that the subject is allowed to acclimatise to its new surroundings for at least 30 minutes prior to acquiring any data. Connect the I2C output of the PowerLab to the I2C input of the NIBP controller. With BNC cables, connect the pulse signal output on the back of the NIBP controller to one of the analog inputs on the front of the PowerLab, and connect the pressure signal output on the back of the NIBP controller to another of the analog inputs on the PowerLab. Connect the pulse transducer to the pulse input connector on the front of the NIBP controller, and connect the pressure cuff to the cuff connection. Select the appropriate pulse range on the front of the NIBP controller. The maximum cuff inflation pressure can also be selected on the rear panel. In LabChart, set up two channels, one for the pulse signal and the other for pressure. You may also like to use cyclic measurements in the third channel to calculate heart rate from the pulse signal. The pulse channel range should be set to 50 millivolts, and the pressure channel range should be set to 1 volt. Units conversion should be applied to give 0 volts equal to 0 millimeters of mercury, and 1 volt.
So this is how we actually just calibrate the system, because these systems will record everything in volt or millivolt. So we need to tell them the correct unit. So if it is pressure, we have to say them as mmHg is the correct unit. So
equal to 300 millimeters of mercury. Push the start-stop button on the front of the NIBP controller to begin a measurement cycle. The pump should start and the tail cuff should inflate. Observe that the pressure waveform climbs up to the...
So you see, the first channel is for pulse, and the second channel is for pressure, and third is they're used for heart rate. So once you start recording, pulses start coming like this. You press the button, the pressure will go up. At some point, it will block the pulse. Then it will automatically start deflating, and when first pulse will come, then this systolic pressure.
Preset maximum cuff pressure. The pulse signal should start to decrease as the cuff starts to occlude the blood flow. When the maximum cuff pressure is reached, the pump will stop and the pressure will begin to drop slowly . As the pressure drops, the pulse signal will start to increase again. Consult the associated example data file and PDF document for a step-by-step guide to estimating actual systolic pressure and the derivation of diastolic pressure from data recorded in LabChart with the NIBP system.
So it's ethical, no need to kill animal every time, and you can use the same animals for longer period. Okay, this is pressure volume foundation system. So we'll be talking more about that in next session. This is from Miller, and this is to know that when you want to record pressure as well as the volume of the blood which is present inside the ventricle, you need this system, and it gives you a nice PV loop, the structure and the parameter of that. It is supplied with 8-channel PowerLab and software and the hardware. So we have a whole session for that. Just quickly, because when we are talking continuous BP recordings, we have got a system for human also, if anyone may find it interesting. So this system will give us continuous blood pressure from human. This is what we were just actually having demo in the morning session when we were talking about human more. It's gold standard system, and I think it's the only one system is where you can record continuous BP, the raw signal, not like the clinical or diagnostic one, for research purpose. When we talk about flow measurement, we have from ADInstruments, which is laser Doppler flow measurement system, and this is the system is widely useful when we talk about non-invasive flow measurements, like measuring flow from like cerebral flow, right, or skin flow, or flow from some mental cavities and all. It comes with multiple probes, like pencil probes, needle probes for different applications, and it gives us arbitrary flow, right? It's not like the real-time flow. It gives us changes arbitrary in the flow, and it's qualitative more. But it's like we need less surgery. We don't need surgery in this. It's just totally non-invasive. Transonic. If we talk about the real-time flow measurement, we have these gold standard systems, which comes with like perivascular, if you're talking about animal or in Vivo recordings, and tubing, if you're talking about laboratory piping, and if you want to flow something in the pipe and you want to measure, so we have tubing systems. So we have got two experts from Transonics. We'll be talking and we'll be having a demonstration for that, right? So you'll get into interact with any of us, and so we won't take much time here. Let's talk about oximetry. So if it comes to measure the oxygen saturation level to blood pressure or to blood in the human or animal, we have these oximetry sensors for human, for animal both. So we got, it's a really simple device. There's no rocket science. This is just like we connect it to PowerLab and we connect it to the ear clip or finger clip or tail wrap, and just straight away we get how much oxygen is present in the blood of any animal or a particular subject, right? So it's like 90%, 95%, so a whole wide range of this. So this is still all about ADInstruments introduction and ADInstruments solutions what we have.